Hey, welcome to The Explainer. Today, we are going to crack a secret chemical code. It's one that's happening all around you, all the time, even right now inside your own body. We're talking about acids and bases, these kind of invisible forces that make our world taste, feel, and just work the way it does. So, first up, let's just look at where this chemical code shows up in places you might not even think about, starting with some really familiar everybody feelings. Think about it for a second. Have you ever really stopped to wonder why biting into a lemon makes your face pucker up with that sour taste? Or why, if you get some soap or cleaner on your hands, it feels so slick and slippery? It feels kind of random, doesn't it? Well, it's not. And there it is. That's our answer. It all comes down to these two families of chemicals. They pretty much govern our sensory world, and almost every liquid we run into fits into one of these two camps. So the real question is, what actually makes something an acid or a base? To get that, we have to zoom in. I mean, way in. We're going to look at the secret code itself. See, at the microscopic level, it's all about these tiny charged particles. They're called ions. So what is an acid? Well, at its very core, any liquid that has a whole bunch of free-floating hydrogen ions, that's the H+ you see right there, is an acid. The more of those H+ ions it has floating around, the more acidic it is. Simple as that. And on the flip side, you've got bases. A liquid is called a base if it's packed with what are called hydroxide ions, or OH- ions. Yeah, it really is that straightforward. The entire difference just comes down to which one of these two ions is calling the shots. And this is where the science connects right back to what we experience every day. Those H+ ions in acids, that's what gives us that sharp, sour taste in things like lemons or vinegar. And meanwhile, the OH- ions in bases, they're the reason things like cleaners and even toothpaste have that slick, almost soapy feeling to them. Okay, so if it's all about how many ions are in a liquid, how in the world do we measure that? Well, that brings us to our next tool. We're going to see exactly how scientists decode all this chemical information. You can just think of this pH scale as a kind of chemical ruler. It's awesome. It gives us one simple number that tells us exactly how acidic or how basic something is. And it's all based on the concentration of those hydrogen ions we talked about. And the scale itself is super easy to understand. It runs from 0 all the way to 14. Anything that's below a 7 is an acid, with 0 being the absolute strongest. Anything above 7 is a base, with its max strength hitting at 14. And right there in the sweet spot, at a perfect 7, that's neutral. Now, this is where it gets really practical. Look at this. The hydrochloric acid in your stomach, whoa, that's down at a pH of 1 or 2, super acidic. Lemon juice is right there with it. Then you have pure water, our perfect neutral, at 7. And as we go up, you get into the bases, like baking soda, which is around a 9, all the way up to something like drain cleaner, which is a hardcore base at a pH of 14. But wait, not all acids are created equal, right? The difference between a strong acid, like the one in your stomach, and a weak one, like the citric acid in a lemon, is all about how completely they break apart in water. It's a process called dissociation. Strong acids basically release all their H+ ions at once, which makes them super reactive. Weak acids, on the other hand, they only let go of some, which makes them way less reactive and, safe enough to put in your lemonade. Okay, so we've cracked the code. We get it. Now let's see how knowing this stuff is actually useful, in our day-to-day lives, from inside our own bodies to the stuff we keep under the sink. Your body is just this amazing chemical factory. That super strong acid in your stomach doesn't just break down food, it's also your first line of defense, killing off nasty bacteria you might swallow. And that burn you feel when you're having a really tough workout? Yep, that's lactic acid building up in your muscles. So what happens when your stomach gets a little too acidic? You might get heartburn and reach for an antacid. This is a perfect example of this chemistry in action. You're basically swallowing a mild base, and that base goes down and starts a chemical reaction called neutralization. It literally turns that harsh acid into harmless water and gas. And poof, you get relief. Pretty cool, right? And it's not just our bodies. Our homes are full of this stuff. I mean, look at how many common products are bases. Soaps, detergents, cleaners. That makes sense, right? We need that slippery property for cleaning. And on the acid side, you've got everything from car batteries to foods like yogurt. We are constantly relying on these properties, most of the time without even realizing it. So here's the bottom line. This isn't just some abstract chemistry lesson. Understanding the difference between an acid and a base actually helps explain so much about the world around you, from the foods you eat to the way you clean your house, and even how your own body works. So, now you're in on the secret. You have the code, the H+ and OH- ions, and the pH scale to measure them. So my question for you is, as you go about the rest of your day today, what other hidden acids and bases are you going to spot? Keep an eye out, you'll be surprised.